This is part 3 of section R.5. We're going to look now at factoring a second degree polynomial using grouping. There's more than one way. When you've seen these ax squared plus bx plus c, second degree, highest power is 2, this trinomial, you've probably used another method like a trial and check method. Some people know that little box method. That's fine to use. This is just another tool to do it by grouping. So it says you can factor by trial and error or grouping, and I just want to show you this little trick because sometimes it's a little faster. But if you can do it without this method, that's fine, but sometimes they can be pretty difficult doing trial and error. Okay, let's look at grouping. And remember, grouping requires 4 terms, but that only has 3. So the steps involved here are going to make us help us write this as a 4-term polynomial so we can use grouping, because we can't just use grouping with 3 terms, right? As always, the first thing you do, factor out the GCF. That'll make your life easier if there is one. Then you want to find a pair of integers whose product, if you multiply them, is the same as a times c, the a from your trinomial and the c, and whose sum is b. Then you're going to write the trinomial as a 4-term polynomial using the integers you found in step 2 for the middle term. So that middle term is going to get split into 2 terms, and now you'll have 4. Then you do the grouping method, and then you can check. I mean, we should check all of these, really. You should always check them, but I'm not taking the time to do that right now. But I probably will show you at least one here. Okay, so let's go with the steps here. Our first one, 6x squared minus x minus 2. Is there a GCF? No, there's not a GCF this time. Okay, let's move on. Find a pair of integers whose product is a times c. Well, let's carefully identify a, b, and c. A is 6, b is -1, right? And c is -2. So a times c is going to be 6 times -2 or -12. So I need a pair of integers whose product is -12. And when I add those two together, I need to get -1. Now, you know, sometimes this is where that trial and error thing can take a lot of time, but I like to just write down what are some integers that multiply to -12, right? So I can multiply -2 times 6, but when I add those, do I get -1? No, I'm going to get 4. Or and look, if I did 2 times -6, that's -12. But all that does is change it to -4. So I really didn't even need to try 2 and 6 again. It doesn't matter about the signs. I'm not going to get a 1. So that's the thing you'll start realizing. You don't really have to try the other one because it's just going to change the sign. If it wasn't, if it had been 1, I would know I was almost there by changing the sign. So let's look at how about -3 and 4. That's -12, but when we add, we get 1. So that tells me, aha, I just need to change the signs, 3 and -4, and there it is. They multiply to -12, they add to b, which is -1. These are my 2 integers that I found in step 2. They multiply to a times c, and they add to b. So now I'm going to write the trinomial, the 3-term polynomial, as a 4-term polynomial using these integers. So this is going to be now equal to 6x squared plus 3x minus 4x minus 2. There's my -1x. It's still the same thing. It's just not simplified, right? But it's still exactly the same. Okay, now we factor by grouping. Remember grouping. Group the first 2 terms, and we group the second 2 terms. Now, here's a trick. We didn't see one like this before where there was a minus right here. The ones we worked before had a plus. If we put a minus right here, everything inside here gets changed. The sign gets changed, which might be fine for the 4x. But if I write -2, then I'm going to have minus 2, and that's not what it is. That would make it plus. So here's what I do to keep myself from making a mistake. Always put a plus sign there. I don't care what's here, I put a plus, and then I just put these in here exactly as they are written. Notice then I don't have to worry about, oh yeah, I got to change that sign. If I put a minus there, that'd have to be a plus. I don't want to have to remember all that. So always put a plus sign and then just write them as they show. Okay, and then factor by grouping says now look for the common factor here. 6 and 3, we can pull out a 3, x squared and x, we can pull out an x, and that leaves behind x plus, or 2x, right? 2x plus 1. 3x times 2x is 6x squared, 3x times 1 is 3x. Good. Now, notice I could just leave those negatives in here, but remember the idea of factor by grouping. I'm hoping that my next pair that I have left is 2x plus 1, because if it is, then I can factor by grouping. So let's just see. If I write 2x plus 1, if it's going to work, what has to come out? Notice then I've got to pull out a negative 2. Yeah, if I pull out a negative 2, there we go. Now I have these two terms, and they have the 2x plus 1 in common. That's what I'm looking for. Okay, so 2x plus 1 times 3x minus 2. We got it. If you FOIL this, let's do it for our check. If we FOIL, we get first times first, 6x squared minus 4x plus 3x minus 2, which simplifies to 6x squared minus x minus 2, our original problem. Okay, let's do one more of these. Start with the GCF. Again, we don't have one, but we always want to look for it. Okay, let's identify our A is 8, B is 10, C is negative 3. So A times C is 8. Whoops, A times C equals, let me use an equal sign here, equals 8 times negative 3 or negative 24. So I need to get negative 24 when I multiply A times C. I need to get 10 when I add. All right, let's try some. To get negative 24, I just like to start with like the lowest integer and then what I'd multiply it by. So I multiply 2 times negative 12, that's negative 24. Add those, I get negative 10. I'm looking for positive 10. Aha, so I know it's going to be negative 2 and 12. There it is. That didn't take too long, did it? All right, so we rewrite our 3-term polynomial as a 4-term polynomial using these two new integers. It's still the same polynomial, just not simplified in the middle. Okay, we had a plus sign here, so we don't have to worry about that little issue that I showed you before. Group them. And see, trial and error or trial and check, whatever you learned before, it works. But sometimes with numbers like, these, it's easier to do this because you're not really having to trial and check much of anything. It just kind of falls into place. Okay, common factor here of 8 and 2 is 2, and x squared and x is x, leaving behind 4x minus 1. And here, 12 and 3, we can pull out a 3, and 4x minus 1. So it's going to work because these two terms have a common factor of 4x minus 1, and that leaves behind 2x plus 3. And I'll leave the check to you, and we'll move on to our next video.